Okay, what I want to look at here is beats, and in the next video you'll see mathematically how we work out beats. So if you think this explanation isn't very mathematical, then that's okay. We've already looked at combining of waves, and we saw that when you combine two waves in phase, you get twice the amplitude. Now that's in phase. That was with the same frequency. We've got the same wavelength, which goes without saying if they're in the same medium, and the same amplitude. Alright, so those are the conditions for just the normal combining of waves. But if you want to look at beats, then you're not going to be looking at a phenomenon that's got the same frequency, same wavelength, same amplitude. The thing about combining of waves, and hopefully we'll show you this in class, or you may have even seen it in year 12, when you have the same frequency and it's coming from two sort of sources, so if our sources are like this, the waves are coming out, the waves from over here are coming out, and then you get this whole interference going on. So if these guys are in phase, these two speakers, then you'll get places where you get a strong maximum, so the sound is louder, and that's where you're getting the constructive interference. Where the wavelength that they've traveled to is always half a wavelength difference, you're going to get these quiet zones. That's your minimum. So you've got maximum, minimum, maximum, minimum as you move around. And that's all related to the fact that you've got constructive and destructive interference. These are same frequency, same wavelength. They're in phase at the start, that because they cover different distances to different locations, they get out of phase. So you get this line where they're maximums and these lines where they're minimums. You've got to be able to describe the difference between that sort of combining and the whole beat thing, which we're going to look at now. With the beat thing, you've got waves which have slightly different frequencies. Alright, so you've actually got something that's going to happen because of that slightly different frequency. It's going to be this variation in amplitude or intensity of the sound in the same place. So with normal combining, you have to have different locations for the maximums and minimums. With beats, with the same location, you get a changing intensity, and that's why we call it a beat. So you've got these two different frequencies, we'll call F1 and F2. Alright, now they will combine, and because they're not in phase, alright, they can't stay in phase because they're different frequencies. So at the same location, sometimes you're going to be together and louder, and sometimes they're going to be destructively interfering and quieter, and they'll do that at the same location, so you'll get this beating. And the beating has a frequency of F1 minus F2, so it's really easy to work out. If you've got 800 Hertz and 802 Hertz, then the beating frequency is 2 Hertz. You'll get this beating twice a second. The other thing to remember about this beats thing is that the actual wave will have an envelope that looks like this. Alright? Now, what you're actually seeing, and you're saying the beating frequency is 2 times a second. So if that's a loud noise, then 2 times in a second, so from here to here, you would have heard 2 beats, and that whole process would have taken a second. So the beating is F1 minus F2, 2 Hertz. What's this in the middle here? Well, that's the actual wave. The envelope is just the fact that the combined wave is going up and down in intensity. The actual frequency of this wave that's inside the envelope is an average of your two frequencies. So the frequency of these two together, the average, 800 and 802, would be 801. So the new wave has a frequency that is F1 plus F2 divided by 2. That's the new frequency. and it's an average. The beating frequency is this. Now, the thing to remember about describing this is that it happens at the same location. Because the waves are slightly different frequencies, they can't stay in phase. When they're in phase, you get the constructive interference and you get a loud noise. When they're out of phase, you get the destructive interference and you get a quietness. And this is what gives you the beating. So this is time moving on, but it's at a fixed location. So x would equal x naught at a fixed location. So this one varies in time at the same place. This one varies in place. For the mathematical explanation of beats, watch the next video.